Equilibrium is discussed quite often when we're dealing with industrial processes. So if you're a chemical engineer, you're going to be trying to identify the ways that you can manipulate the surroundings of an equation or of a reaction to get the desired results. You want the most product with the least amount of reactants. So we want the greatest output, the fastest way possible, with the least amount of cost, and the least amount of energy input, because not only does that energy input cost environmentally, but it also is a monetary cost. While we cause the least amount of waste possible, if we're increasing our waste, then that's more cost for us because we have to find a way to dispose of the waste products. So we need to consider kinetics and equilibrium in dealing with these different processes. We need the reaction to happen quickly at a fast rate and needs to be able to sometimes be in equilibrium. One of the most common processes that you will hear about and definitely will see on an IB exam is about the Haber process, which is how we form ammonia. The reaction for it is nitrogen gas plus hydrogen gas forms ammonia. The first step, we take nitrogen and hydrogen and we heat them. They pass it over a heated catalyst, and then we reach equilibrium. In the ideal world, we would have a large pressure and really cold temperature, but the high pressure is expensive and dangerous. So that's not ideal for us. The low temperature means that our rate is going to decrease, so that's not good for us either. It would take too long. The second step, we take cooler temperatures, condenses the NH3, we get that NH3 liquid out, and the other gases are sent back to keep reacting. So we have an image here. A common one, if you type in Haber process, you'll see something like this. We've got the gas being fed in, reacts, goes over the iron catalyst, we start cooling it, some of it's going to get condensed, some of it's going to go back into reacting, and it's just going to keep going on and on until we get just ammonia. Skip that video for now. The contact process is another one that you're often going to see in IB assessments, and that is how we form sulfuric acid, H2SO4. So the first step, sulfur dioxide, is produced generally by burning sulfur in air. So we just need the oxygen that we're dealing with. So sulfur gas, or sulfur solid burnt with oxygen around it, forms SO2. Clearly we're not there yet because we need to form sulfuric acid. So the second step, we take that SO2, we react it with more oxygen to form SO3, sulfur trioxide. The temperature for this is around 400 degrees Celsius and nearly standard pressure that we deal with this procedure. And we have a catalyst for this one, vanadium oxide. In the third step, we take that SO3, react it with some water, and that's where we get our sulfuric acid, H2SO4. This is also a process that happens just in our atmosphere. We get some sulfur dioxide gas as a result of car exhaust that can turn into sulfur trioxide, and we can actually get some sulfuric acid in our atmosphere that can come down in the form of acid rain. The process here, another image for it, so we've got it, we're reacting them, we have different steps where we end up getting them, and we have parts that can go back if they're not fully reacted.